Okay, here's our notes on mixtures, elements, and compounds. When scientists like to classify things, classify matter. And one way that scientists classify matter is by its composition. Ultimately, all matter can be classified as mixtures, elements, or compounds. Why isn't it a good idea to classify matter by its phases? Because one kind of substance can exist in more than one phase, okay, such as water. Okay, that can be a solid and a liquid, and matter changes phases easily. Why isn't matter classified according to its physical characteristics, such as color? Well, that doesn't make sense, because if you took a pot of gold and a sunflower and the sun, they're all yellow, but they're not the same when you really look at them. So science wouldn't find very useful groups if they tried to classify those all together. So when scientists are classifying, they ask themselves these questions. Is the matter uniform throughout? Can it be separated by physical means, meaning like pulled apart? Or can it be separated by chemical means, meaning that it would have to undergo some kind of reaction to be separated? By asking these questions, scientists can classify matter into mixtures, elements, and compounds. A mixture is just two or more substances that are not chemically combined with each other that can be separated by physical means. So the substance is a mixture, and they retain their individual properties. Okay, so an example of that would be like a bowl of jelly beans. I can separate, I don't like the black jelly beans. I can pick out the black jelly beans without having to undergo some kind of chemical reaction to be able to do that. So I can just pull them out. Solutions are also mixtures. Okay, so like salt water or Kool-Aid. You have a dissolved solid into the liquid, but it's still a mixture because you can evaporate that liquid and get the solid back. So solutions is a special kind of mixture where one substance dissolves into another. Those are also called mixtures. Elements. Simplest form of a pure substance. They cannot be broken down into anything else by physical or chemical means. That's what elements are. Or they classify them as compounds. Those are pure substances that are the union of two or more elements by chemical bonds, and they can be broken into simpler substances by chemical means. We'll get further into those as we go. So, the first question is, can it be separated by physical means? If so, it is a mixture. And I gave the example of the bowl of jelly beans earlier, but like cereal can be separated. You pick out the raisins if you don't like raisins in Raisin Bran. Kool-Aid is a mixture because you can evaporate the water and you'll have the sugar left behind. If you cannot separate it by physical means, that means it's either an element or a compound. To decide if it's an element, let's talk about what elements are. Elements are the simplest pure substance. An element cannot be changed into a simpler substance by heating or by any chemical process. Elements are the smallest particle of an element, or the smallest particle of an element is an atom. An atom is like the basic building block of matter. There are more than 100 known elements in the universe listed on the periodic table. These elements combine in such ways to create millions of compounds. Elements are made from atoms. Atoms of the same element are alike. Atoms of different elements are different. Okay, so they're not all created the same if you're talking about different types of elements. An atom is the basic particle from which elements are made. So the parts of an atom. In the center of an atom, you have a nucleus. Okay, that's right here in the nucleus. This is where the protons and the neutrons collect. Protons are positively charged and they're located in that nucleus. So the protons in this atom that we're looking at here are red. Okay, they've got a plus sign on them because they're positively charged. There's also neutrons. Neutrons do not have a charge. They are neutrally charged, and they are also located in the nucleus. Those are the ones with no symbol on them, the blue, inside the nucleus. Then we have electrons. Electrons are negatively charged, and they are located around the orbits of the atom. Okay, those are the yellow ones with the negative symbol on them. The periodic table was designed in 1813. It was a system of representing elements with symbols. Each symbol consists of 1 or 2 letters. 2 letters are needed for a chemical symbol when the first letter of the element's name has already been used. So if it represents another element, they can't have 2 elements having the same symbol, so they had to use maybe a second letter. So here are some common elements. Aluminum is Al, bromine is Br, calcium is Ca, carbon is just C, gold is Au, helium is He, hydrogen is H, and nitrogen is N. Here is a picture of the periodic table. It's broken down into different families. Okay, you've got the alkaline metals, and then we have a gas over here with hydrogen. Then we have the alkaline earth metals. The center part with the pink is all of our metals. Okay, and then we've got more metals here with the blue. And then we have the green are non-metals. And then the blue, the far end, we have noble gases. Okay, so our periodic table is divided up into families also. Okay, reading the periodic table, each element has its own box. You saw all those different boxes on that periodic table, and there's over 100 of them. The box gives you information about each of the elements. At the top of the box, you'll see an atomic number. That atomic number tells you how many protons, remember those are positively charged particles in the atom, that the atom has. So in this case, carbon has 6 protons. The atomic number also tells you the number of electrons. Electrons are the negatively charged that go around in the orbits of the atom. There are 6 of those. The atomic number tells you the number of protons and the number of electrons in every atom. It's the same. For protons and electrons are always the same for each atom. The atomic symbol is in the middle, or the letter. And then at the bottom you have the atomic mass. You can calculate, with the atomic mass, you can calculate the number of neutrons that are in the center of the nucleus by taking the atomic mass, which in this case is 12.01, minus the atomic number. So I could calculate that it has about 6 neutrons inside the nucleus of the atom, because I can take 12 times 6, or 12 minus 6. And then we have compounds. Compounds are also pure substances, but they are made from more than one element, and they are chemically bonded together. Water is an example of a common compound that we know, H2O. Water can be broken down into simpler substances. We can separate the hydrogen from the oxygen, okay? And I said that water is H2O because the H and then the 2 tell us how many hydrogens are in the atom. And then O tells us that there's only 1 oxygen. So even their formulas tell us about the compound and what they're made up of. Okay, please make sure you fill out your notes and then show me that paper when you are finished.